Hi everyone, my name is Owen Reich and I'm out here at the Bask Retreat Center construction phase. Over here to the side, we have one of our biggest projects, which is an underground greenhouse. And what I mean by underground greenhouse is that the roof will be roughly at soil grade, and the actual cavity in the ground is where we're going to grow all of the plants. And the reason that we're doing this is manyfold. First and foremost, the insulation of the ground will allow for the greenhouse not to heat up as much as one that's built on grade, like a normal greenhouse. So having it under the ground like that and having mounded soil on either sides is going to insulate it naturally with the clay soil. Then we're going to further insulate it with retaining walls, actual insulation material, and then we're going to fill the inside with other insulative materials so that any air that's inside of the greenhouse space can be controlled temperature-wise. So if it's 90 degrees in the greenhouse and we want it to be 70, we're going to have systems in place to allow for that without running electrical to this structure. It's what's called a ground air heat transfer system, and it utilizes the air in the building being sucked underground and cooled to the earth temperature of roughly 52 degrees. Then the air will be pumped out with a low voltage fan and circulated back into the greenhouse in order to cool it. The same concept will work with the exact same system to heat the greenhouse in the winter. We will take air from underground at 52 degrees and pull it into a greenhouse that might be, say, 35 degrees and heat the air up. As we build this greenhouse, we're going to be documenting the different phases and layers of the system. Another part of that system will be roughly 100 to 150 55-gallon drums full of water. And those are going to be on the north-facing wall over here. So basically, we'll have a wall of barrels, and those barrels will be heated by the sun in the winter from the south. And as the light transmits through the greenhouse, it will heat that water system of roughly 3,000 gallons of water, and that will radiate heat at night into the greenhouse during the winter. So instead of spending a bunch of money on utilities, heating, cooling, so forth, what we're going to do is invest in the infrastructure of the ground air heat transfer system and the thermal mass wall on the north interior. What that gives us is ambient heat and the ability to moderate the temperature through ventilation and not through forcing air out of the greenhouse and sucking new air in. So this system is rather complex in terms of how it's designed, but once it's implemented, it's largely a passive system. What that means for us is long-term a much lower electrical bill and the ability to utilize nature's thermoconductive capacity and utilize it in such a way that what we're doing doesn't actually generate exhaust or any kind of pollution. Our hope long term is for people to be inspired by this build and to implement this sort of design in their own homesteads, nurseries, schools, everything. This system was originally called a Wally Penny, and it was invented in Bolivia in the 70s. However, that system was built around the concepts of low-cost, native materials utilization and high return for the low cost. So basically, if you were trying to grow food out of season, a Wally Penny greenhouse was great in Bolivia. Here, we're doing it to a much greater level because this will also be a place where teaching will occur, as well as production of a variety of non-food crops, mainly for habitat restoration on site, as well as parts of our curriculum that Bask will have in terms of specific thematic elements. And so it will also be used in the winter to overwinter non-hardy plant material, for example, lavender or a tropical fern or something like that. And so it's going to have many uses, and eventually it'll be a full 8 to 10 feet wider than the current trough, and that will account for more space for people to come in and enjoy the space and not have to deal with the vegetable production and so forth. So it's going to be a multifunctional facility. And we've already broken ground, as you can see. However, the next step will be to excavate the trenches for those ground air heat transfer lines. And then once we do that, we'll have a footer installed and then build a cinder block wall. Once the cinder block wall is in place, we'll insulate it and paint the interior surfaces white and seal it, because the biggest issue with an underground greenhouse in the southeast is humidity. In many parts of the world, mainly in Canada, they're building these underground greenhouses to encapsulate the existing heat and not let it escape. Our problem is not heat. Our problem is water vapor. And so this design will have much, much more ventilation on the end walls and also in the roof. And by doing so, we can transmit that heat out of the greenhouse without using electrical systems.